Hey AP Cal, we already talked about the power rule and the constant rule. We already talked about the logs and exponential for derivatives, for integration, sorry, not derivatives. We already passed derivatives. So now we're going to move into our trig functions. So we're going to talk about trig and our inverse trig functions, and we're going to find integration of those functions there. We're going to do indefinite and definite integrals. So we're going to start off with the definite ones first. And so first off, before we even do that, let's go through these rules that we have here for indefinite integrals, or for integrals for trig functions. And these are considered indefinite because, again, we have the plus c on the back of it. So integration here for a sine is negative cosine plus c. Secant squared, the original was, if you take derivative of tangent, that gives you secant squared. So we still have secant squared, we go back to tangent. Derivative of secant squared, it's amazing, secant x tan x. So here, if you take the derivative of that, that will give you a negative portion here. So in other words, the derivative of cosecant, it will be a negative cosecant cotangent. But if we want to have a positive cosecant cotangent, it means we put a negative in front of it, and that will cause it to balance out correctly. So remember, the derivative of a cofunction is always a negative. So the derivative of this function would make it a negative cosecant cotangent. So we put a negative in front to make it a positive cosecant cotangent. Over here, derivative of sine is cosine. So the integral of cosine has to be sine. Then here, derivative of tangent of cotangent is negative cosecant squared. And so to make it a positive cosecant squared over here, we have to throw in another negative. So derivative of cotangent is negative cosecant squared. We put the negative in front, makes it a positive cosecant squared. Cool. Now, derivative of secant, is secant tangent, and that's what we have right here, secant tangent. So not bad, not hard. We can do this. So all these rules, again, they're backwards of what we did with derivatives. So again, these are our derivatives, and these are the original functions that we start off with. Same things for this here. All right, so let's go ahead and take a look at this one. You might, with our notes, should be example 3. So we can call example 5 if you want to, but it actually is example 3 here for us. Example 3. Okay. And so here we're going to find the integration of it, and then we're going to go ahead and work it out. And actually, because it's a definite integral, so therefore we definitely have to have an answer for it. All right, so we're going to do our derivative here, integration, integrated. So with this, remember we talked about at the beginning, we talked about sum and difference, how we can break it apart and do the sum of this one, the integration of this one, integration of that one, and then add them together. That's what we're going to do here. We're going to integrate 1 from pi over 2 to pi. And then we're going to integrate cosine. And we put the x for both of them because, again, we're talking about taking the derivative with respect to x. All right, so here with both of these, we're going to go ahead and find the integral of that integrated. So here, that would be x to the 0 power. And just really quick off to the side, I'll do this right here. Number 1, same thing as saying x to the 0 power. We add 1 to that, divide by that new exponent. So technically it's just x to the first power over 1, which is just x. So therefore, for this portion here, this will be x. And again, we haven't dealt with the a and the b, the endpoints yet. So we have to deal with that next. All right, and then next portion here, the derivative of cosine. Derivative of cosine, that's one of our new ones. Sorry, not derivative, but integral of cosine. That's one of our new ones right there. It's sine. So here, if you look at just the rules that we have, that would be sine x. And again, we haven't dealt with the limits for here, the endpoints, the limits, whichever one we call it. All right, so at this point, I should have enough space there. Now we're going to be requiring you to remember the values. Oh, they did it different, but it's okay. And this one here, we do sine pi minus sine pi over 2. Now again, this reminds you that you have to remember your trig values. So first off here, we know this is just pi. And I'm going to move this over to this side over here. And hopefully you didn't write as big as I did, but it's okay. So if we look at sine of pi, you got to remember the values. Hopefully you already know off the top of your head. I hope you do, because that's where we did in pre-cal. So hopefully you guys remember. And my graph is off a little bit. So I'm just looking at the graph here because that helps me remember it easier. So we know we start at 0, we go up to 1, we down to 0. So that means here the sine value, oh, you can't see it. So I remember the graph here of sine starts at 0, goes to 0, 0, goes up to 1, and then back down to 0 here. So for pi, it's at 0. So sine of pi is 0. Sine of pi over 2 is the part that's here, which is 1. And so here, oh, I'm sorry, this should be pi over 2, not pi. My fault. That's pi over 2 right there, my bad. So our final answer is pi over 2, and then 0 minus 1 is minus negative 1, so minus 1. So the trig portion will remind you to know the values. So make sure you are prepared and remember those values for your trig values, or trig functions. All right, so at this point, let's go to B really quickly also, so we can get that done, get her done. All right, so again, we're going to deal with this one, but this one's actually even simpler because secant tangent is what we're dealing with right here. So all we did with this is secant. So here, with this portion here, we could go just have secant x from 0 to pi over 4. And then all we have to do here is go and work it out. And 9 times out of 10, you might not remember your secant values because we didn't spend a whole lot of time in that in pre-cal. We talked about the graphs and everything, but not necessarily the values of secant. But you should remember that from your trig identities, or just remembering that we talked about that secant is 1 over cosine. So for these, I'm going to go ahead and put the values in. I'm going to still work them out like this, or show it out like this. I'm going to still do it that way, but then we're going to go ahead and deal with the trig function that we're familiar with, that we've learned and we've remembered. So I know we all remember this. I know we all do, because we spent time on this. So that's cosine pi over 4, and that's 1 over cosine of 0. Okay, so you should remember these values, hopefully. I hope. We know that at cosine, again, looking at our graph really quick for cosine. Can you see it? Up here you go. Now you can see it. So for our cosine for our graph for cosine, so we know we start at 1 here. So we have 1, then 0, negative 1, 0, positive 1. So when it comes to cosine of 0, that's 1. So here, that's 1 over 1. And when it comes to cosine pi over 4, remember that's between 0 and pi over 2. So that was that middle piece, that was the square root of 2 over 2. So this is 1 over square root of 2 over 2. Oops, sorry, there should be a subtraction sign here, not a equal to sign. Subtraction sign there. And so here we can simplify it down, or we can just keep it as it is. So in this case, we're going to keep it as it is. But first off, before we do that, remember we can't have a radical, a fraction in your denominator, or in your denominator here. So we're going to go ahead and do keep, change, flip, which means we're technically dealing with, and just because I think we're going to run out of space for the work portion of it, I'll put this here. 1 over the square root of 2 over 2. That equals, keep, change, flip is 1 times 2 square root of 2, which in this case, again, we left with this to square root of 2. Multiply both the numerator and denominator by square root of 2 because we can't have a radical denominator. So that's 2 square roots of 2 over 2. The 2's cancel out, and we're left with just, 2's cancel out, so we're left with just the square root of 2. All right, so we're left with, for the first part, square root of 2 minus 1. All right, we're going to stop there and then go to the next part.